What if I told you everything you learned about square roots in middle school was only half the truth? You were taught that you can't take the square root of a negative number, that it's impossible. But what if that impossible number is the secret key to modern physics, engineering, and the very screen you're watching right now? Today, we're breaking the rules of the real number system. Until the 16th century, mathematicians were stuck. Equations like x squared plus 1 is equal to 0 were a dead end because no real number squared equals a negative. But then thinkers like Cardano and Descartes realized that if we imagine a new kind of number, the entire puzzle of mathematics fits together. Today, we're going to decode the DNA of complex numbers. We'll master the imaginary unit I or iota, learn how to handle negative roots, and see why every single number you've ever known is actually part of a bigger system. Let's look at the problem x squared plus 1 is equal to 0. To solve for x, we get x squared is equal to negative 1, which means that x is equal to the under root of negative 1. In the real world, this just doesn't exist. But in the complex system, we define this as the imaginary unit iota. The golden rule: iota is equal to under root of negative 1, while the square of iota is equal to simply negative 1. This is our secret key. Whenever you see a negative inside a square root, you can now extract it as an I. How do we use this in an exam? Let's say you're asked to express under root of negative 5 in terms of iota. Firstly, identify the negative. Think of under root of negative 5 as under root of negative 1 into 5. Now we'll separate the root. This becomes under root of negative 1 into under root of 5. Now we will substitute iota. Since under root of negative 1 is iota, your final answer is iota into under root 5. But here is the trap. Most students forget where the I goes. We prefer to write it as AI, like 5 iota, where A is a rational number. If this is a square root, we often write it as iota into 5. So the iota doesn't accidentally look like it's hiding inside of the radical sign. Now what happens when we mix a regular number with an imaginary one? We get a complex number. Every complex number has a two-part DNA. First is A, which is the real part. It is a standard real number. And then we have B iota, that is the imaginary part, where B is a real number multiplied by I. In FBIC papers, you'll be asked to identify these. For example, 7 plus 3 iota. The real part here is 7 and the imaginary part is 3. Simple, right? Most students think real numbers and complex numbers are totally different groups. But in a moment, you'll see why every number you've ever used, even the number 6, is actually complex. But first, let's look at what happens when the real part disappears. If we have a plus b iota and we let a be equal to 0, we are just left with b iota, like 5i or negative 7i. We call these pure imaginary numbers. But here is the aha moment. What if b is equal to 0? Then we are left with just a real number. This means that the set of real numbers is actually a subset of complex numbers. As the key fact in our textbook says, 6 can be written as 6 plus 0 iota. Therefore, every real number is a complex number. Now it's your turn to test your logic. If you have the number under root of negative 64, how would you write that as a pure imaginary number? Is it 8, negative 8, or 8 iota? Think about the steps we just did. Extract the negative as iota and take the root of 64. Drop your answer in the comments. I'll be hearing the correct ones. This is a classic 2-mark conceptual question for your board examination. You just learned the logic that puzzled the greatest minds for centuries. From the imaginary unit I to the full A plus B iota structure, you now speak the language of complex systems. If this step-by-step breakdown made the impossible simple, hit that like button and subscribe to our channel. We're covering the entire class 10 syllabus so you can ace your exams with confidence. Keep practicing and stay curious, and I'll see you in the next solve along.